All right. Hey everybody. Going to be talking through two things today. One being talking a little bit about Layer Zero Read, why we built it, what it does, and how it's used currently in the ecosystem. And then sneaking in QMDB, because that talk was vetoed later on, so we'll just squeeze them both in. So, Layer Zero. Who are we right now? What do we do? Largest interoperability protocol currently in the space, 120 plus blockchains, 144 million messages, 75-ish plus $1 billion of value transferred, closing in on $100 billion, which is awesome. 71.3% market share when it comes to just pure messaging volume, 60% market share when it comes to value transferred. And the thing that's interesting there is that the market share delta between those two means there's a not at all insignificant percentage of the messages that are starting to be non-value transfer, which is really interesting. And so what is Layer Zero Read? Read is the ability to take any data from any chain over any period of time. And so you had this problem historically, if you wanted to access any state data from, say, Ethereum. Originally it was just you couldn't get it. You needed some external oracle to provide you that data. Most people can't get these oracles to even respond to them, let alone on like a very long period of time. So this was like hard to access. And then it was, even if you could access the data, it was both slow and expensive. So you can imagine trying to fetch something from Ethereum. Who owns a Pudgy Penguin or a Bored Ape? What is the current price of the ETH USDC pair on Ethereum, on Uniswap v3? Any of these pieces of data, you would have some latency coming out of the chain you were requesting it from. You'd grab a moment in time snapshot of what is the thing at that exact moment, which is obviously kind of manipulatable to attacks on price or just like moment in time snapshots. And then you have this 3-minute and 15-second latency coming back to deliver the data. And so not only did you have pure moment in time data, you had really stale data by the time that you needed it. So Read is designed to sort of address all of that. Any data, any chain, any period of time. So what are some of the use cases? One of these is election market that got settled in the last election. Wintermute introduced basically the ability to create any market in a prediction market style, but they need a way to like resolve what actually happened there. They used Edge, Chaos Labs' Edge Oracle for this, and so the election happened. There were markets that lived on any of these chains, so anybody could buy either side of this market on any of these chains through just like an AMM structure. Edge through Chaos posts the election result onto Arbitrum, and then every other chain just absorbs that data basically through Read to settle all the election markets simultaneously. Shadow assets is something that we see more and more now for anything that needs auth or ownership. So you can imagine a world where your authentication lives on a given chain. This could be World Chain. Again, this could be the ownership of who owns this Bored Ape or this Pudgy Penguin. One thing we saw that was cool was Ape Chain itself. They didn't want to actually transfer the ape, right? You don't want to be bridging this asset because there's a bunch of stuff that was built on Ethereum that relies on those ownerships. You have some traits or some benefits that you've gained in that ecosystem, and to need to move the asset might actually like harm the end user. So this shadow asset was the ability to prove with Read that you own the asset without actually being able to move this. And we actually saw this in a couple of games prior. Some of the biggest games, Proof of Play, Pirate Nation, a couple of these, basically what they really wanted is, hey, we want our assets in our ecosystem to live on this chain. We want people to play the game. We want people to have everything that they own here, but all the liquidity is on Ethereum, right? So like we want the real assets to be traded to live back in Ethereum. And so what they really want is kind of like an ad hoc oracle that's a representation of what do you own, and then when that changes, you can just, there's a couple of really interesting ways I won't get too deep into it. You could use a Bloom filter, do some really cool stuff here. But basically, without needing to move the asset back all the time, without needing to touch Ethereum state, and obviously touching Ethereum state is the expensive part. Back when ETH transactions were $15 to $20, again, you want to fetch a single piece of data like, hey, who owns this NFT? Or like somebody just sold this. You're going back. You need to do a write on Ethereum to request what you're trying to fetch, and then another write on Ethereum to send the response back. So you're paying $40 to $60 in Ethereum L1 fees just to get the response of what you're doing. With Read, you don't ever actually touch ETH state. You're never writing anything. It's read only. And so you write on your extremely cheap chain that costs 1 penny, hey, fetch me this data or this construction of data, and then you immediately get the response back next block, right? So there's no latency, there's no cost, you're not touching Ethereum state at all. And so what that enables you to do is a bunch of really cool things, but one, you can do a lot of stuff that you would cost $60 before. So the world of actions you can take when you're paying $10 to $60 per action versus the world of actions you can take when you're costing a penny per action is just night and day difference. And that in its own is super exciting. So one of the things I was most excited about was this ability to stream pricing data. So you can imagine not just being able to grab what is the current price of ETH USDC on UniV3 on Ethereum, which is great, but I can grab 100 block TWAP, and I can grab it of any long tail asset on any chain, and I can live on some new chain that's spun up, right? We have 120 plus chains right now. I promise you the 118th of them is gonna have a really hard time getting Chainlink or getting another Oracle provider to give them price feeds consistently. It's just always been a problem within the industry. This is the ability to be able to build DeFi constructs around pricing across any formulation that you want. And you can grab, what is this, what is the price in this DEX on Solana, but you can also grab I want 100 block TWAP across these 4 DEXs that live on 4 different chains, and then I want to amalgamate them all and create some price index based on that. And anybody can do this permissionlessly. There's no, nothing custom that you need to write. You don't need to ask us to add an asset. You don't need to ask us to do anything. You can read any piece of state on any chain in real time, and you can apply this sort of external mutations to them, which is really, really interesting in terms of what you can build and what that enables in long-term DeFi. So yeah, that's Read. Super excited about Read. Have seen usage slowly but steadily ramping up. We did it for our own voting. I think you'll see more and more governance across multiple chains use this structure. More people like ApeChain, like a ton of others, are starting to build their own internal primitives on it, which has been cool to see. I've spoken about for a very long time. I've always been much more excited. Value transfer is interesting, but honestly, when we built Layer 0, there were already bridges, right? Bridges existed. The entire point of Layer 0 was that everybody was thinking about these things as purely a bridge. And for us, the insight that we had was value transfer is just a special case of generic messaging, right? Really what you're doing is just sending packets on the internet. It's arbitrary contract invocation with a bytes array. And the ability to take that and express it in any form that you want should unlock a ton of really exciting things, especially as applications become more asynchronous, more data rich across multiple environments. And for the last couple of years, it's pretty much been wrong, right? Almost everything has been value transfer, but I think that is quickly changing, and I think you're seeing applications become more stateful at the application layer. I think you're seeing applications start to lean into not becoming just a single isolated instance across a lot of different chains, but becoming real asynchronous instances. Stargate was one of the first examples of this. So I'll dive into QMDB now, which is the talk that was not supposed to be a talk. So this, I think, is for me one of the more interesting things we've worked on lately, and totally orthogonal to pure Layer 0, right? We've spent a lot of time, probably more time than any other team in the world, in actually digging in to every single VM that we have to go to. And so we built Ethereum, and we've always taken the stance that the protocol must be immutable. The protocol is not immutable, then every application built on top of us has to rely on us for some layer of trust, and that is not an acceptable precondition, and we don't think we ever would have grown to the size that we are now if we didn't have that. But what that means is every single thing that you do is terrifying because you get to basically launch the protocol once. You cannot fix it if there's a bug. This is the same way that Uniswap has built everything for a very long time. So it's really a measure twice, cut once. And so, I talk regularly. We spend probably $5 million a year on audits. I think we're the largest consumer of audits out of anybody. Our Ethereum contracts have been live and in production, since March 2022. so going on 3 years now. Those are battle tested, tens of billions of dollars on them, tens of billions of dollars flowing across them. Launching to a new EVM is quite trivial, right? It's largely just a fork of the same code. Launching to a non-EVM is completely non-trivial. You talk about our Solana program, compiles to 50,000 lines of Rust, which I think is one of the largest Solana programs out there. We talk about Ton. We just went to Telegram. We literally rewrote an entire programming language, Fun C++, on top of the Ton VM in order to build this and help other people build more easily. Talk to Aptos, Move VM, like many of these VMs, we've found crits. We've helped teams patch them. We have to go really, really, really deep because it matters on the security side in every single layer that we go to. And so in doing that, one of the things we've seen is kind of what stresses scaling in each system. And if you look at Aptos' recent Shardines million TPS example that they give, storage was the bottleneck there for each of the shard, right? Each one of the Shardines had 33K TPS, but were bottlenecked by storage. So what is the insight here? And a lot of this insight actually came from our chief architect, who was on paternity leave, and he just started poking around. And I guess because this is the thing that you do when you have a baby, you create a really interesting database. So conventional belief was you must use a searchable data structure, i.e. a trie, and everybody built that way. And the challenge is tries have really significant write amplification, which causes a lot of issues. And the alternative, and the insight that we had, is that actually a log-based DB that's modified to support mutability, exclusion proofs, and historical proofs is actually extremely highly conducive to in-memory Merkleization. And so what does that actually look like, right? It's fast, really fast, 3 million updates per second. And 3 million updates per second is, I'll just look. Compared to state-of-the-art right now, even for unverifiable databases who are not doing Merkleization at the DB level, this is 6x faster than an unverifiable database while doing Merkleization. If you look at state-of-the-art for actual verifiable DBs, which is NOMT, it's 50x state-of-the-art, and it's 92% theoretical optimal on current EVM workloads for disk I/O, which is just like an insane step function. There is no 10x more from here in terms of what can actually be gained. It's really incremental, and so this is a huge step function. We've seen way more interest than I expected in terms of teams wanting to adopt this, because storage has been, you think about any architecture, computer architecture, blockchain architecture, it's really storage, compute, and network, right? And this really creates a lot of compression and solves one of those vectors. And so if you look at overall highlights, 2.28 million state updates per second, over a million TPS, benchmarked at transfers per second in terms of token transfers. Benchmarked with workloads up to 15 billion, which is 10x Ethereum's 2024 state, and have proven capacity to scale to 280 billion entries on a single server. So really massive gain there in terms of what can actually be held and processed. Single read per state access, so order one reads, which is anybody who spent time in computer science, it doesn't get any better than that. In-memory Merkleization on a footprint as small as 2.3 bytes per entry. Efficiently scales across both consumer-grade and enterprise hardware, so small machine's going to be as efficient as a big machine. It's really a lever that you can play with, and available for any blockchain to implement. Everything is fully open source, Apache, MIT, completely available to the world. Received a lot of amazing feedback from within the community, from Uma talking about what this actually means for real-time blockchains and real-time proving, relative to needing to pack an entire block with MPT and having slow proving on top of this. So this gap of latency that's being shifted to being able to pack on a per transaction basis with QMDB. Patrick, I'm a huge fan of at Commonware, talking about him, not believing that this was possible, and Yilong from Mega ETH talking about how we basically, perfectly solved the bottleneck of Merkleization with this. So super excited about QMDB, super excited to share more kind of with the world and see the first group start to implement it. And more or less, hopefully going to keep building things that are genuinely useful to the industry as a whole, open source as much as humanly possible, and help the space move forward. So thank you all so much.